If you're just trying to get through your networking class and Packet Tracer feels like random commands that you're copying, then this video is for you. I'm going to show you static routing in a way that actually makes sense. So that way, your labs will work for you and you'll understand why they work. Hi, I'm Colleen from Mom Teaches Tech, and you look like you're ready to learn today. So let's get started. First of all, what is a static route? Well, a static route is a route you will configure directly on the router. You will tell the router specifically what network you want to go to and how packets should get there. The router will never change the configured route unless you change it. Remember from our previous videos that directly connected networks show up automatically as soon as you configure an interface with an IP address and bring that interface up. If you need to review information about how directly connected networks function and how they show up in the routing table, I'll link to those videos in the description. This is our basic network that we're going to be using. I have two routers here connected to each other through serial 000 interface on each router. You will tell the router specifically what network you want to go to and how to get there. We'll tell the router how to get to another network using a next hop command. Every time traffic passes through a router, that counts as one hop. And when a router forwards traffic to the router directly next to it, that is called the next hop. With that in mind, let's walk through this path and count these hops together. Router 1 forwards the packet to router 2, that's one hop. Router 2 forwards the packet to router 3, that's hop 2. Router 3 forwards the packet to the server, and that's hop 3. So even though the last link goes to a server, router 3 still forwarded the packet, and that's why this is 3 hops. We're learning this right now for static routing, but this idea of counting hops will come back again later when we study how some dynamic protocols think about distance. I want you to watch out, because one really common mistake at this point is trying to configure a router's next hop as a router that's multiple routers away. The next hop is not the final destination router necessarily. The next hop is only the very next router that your router is directly connected to. Router 1 can't send traffic straight to router 3. It has no direct link to router 3. So router 1's next hop must always be router 2 because that's the only router it can forward traffic to next. Each router only knows about its direct neighbor. So each router's next hop is simply the router on the other end of whatever cable the packet is going out. All right, let's look at our command syntax. The command for a static route follows this syntax. From the global config mode, so you need to go through enable conf t and be in global config mode, you'll use the keyword, it's 2 keywords, IP route. And then you list the network ID or the destination network that you want to route to with the correct subnet mask for that destination network. And finally, you list the next hop, which is the router's IPv4 address on the link next to it. So in our case, it would be from, if we're looking at router 1 on the left at 10.0.0.1, the next hop would be the serial link on router 2 at 10.0.0.2. For IPv6, the idea is exactly the same. The syntax changes slightly, but you're still specifying a destination network and a next hop. I'll go over that here briefly, but this is not a video about IPv6 syntax, So we're going to primarily focus on IPv4. That's enough to learn at this point. IP route changes to IPv6 route. And then you still are going to list the destination network just using the destination prefix. And then instead of a subnet mask, because of course we don't have subnet masks with IPv6, you just use slash notation to indicate the prefix length, and then you list the next hop. So hopefully you can see it's very similar, just slightly different due to the changes in IPv6. All right, this is what our packet tracer network is going to look like. If you would like to follow along in my packet tracer demo or try it later, I've created a packet tracer file for this lab where everything's configured except the static routing. It's important to pay attention to our networks and the network IDs. We have 3 networks in total in this topology. We have the 192.168.0.0/24 local area network that's connected off of gigabit Ethernet 0/0 to router 1. We have another local area network 172.16.0.0/24. This local area network is connected off of gigabit Ethernet 00 on router 2. Then we also have a point-to-point network. It's important not to forget about this one. That network is 10.0.0.0/30 with IP addresses of 10.0.0.1 on router 1 and 10.0.0.2 on router 2's serial 000 interface. These 2 IP addresses are the next hop addresses, and we will use these when we configure our static route. So when you hear next hop, this is what we're talking about. The IP address of the router that's on the other side of the link. All right, enough talk, let's lab. Here we have our little network that we talked about, and let's just go ahead and from PCA, try to ping to PCC. Now we haven't configured any routing yet, and so this, of course, is not going to work. We can go to our command line, and let me pull it off to the side. We can see PCC is, let's see, ping, and we want to ping PCC at 172.16.0.2 and destination host unreachable. And this is because we haven't configured routing to get to the 172.16.0 network, and we haven't configured any routing to get back to the 192.168.0.0 network. So let's take a look at our router, and we'll go ahead and verify that by looking at the routing table. So if we just do a show IP route, we will see our routing table here. Stretch this out. We can see both of our connected networks. So as I mentioned, we have the 10.0.0.0 network that's going between routers in our point-to-point connection. And we have our other directly connected network here off of gigabit Ethernet 00, which is 192.168.0.0. But we don't see any routes for the 172.16.0.0 network, and that's what we're going to configure. So it's easy. We just have to go into global config mode. So configure terminal, or conft for short, and then we're going to say IP route. That's our keyword, the network we want to go to. So remember, the network that we want to get to from here is this 172.16.0.0/24 network. So that is 172.16.0.0. And our subnet mask with a /24 is 255.255.255.0. Now the last part of our command is to tell this router where its next hop is to get to the 172.16.0.0 network. And the next hop is on the 10.0.0.2 interface of router 2. So we just tell it that. We just say 10.0.0.2. Enter. Now, if we look at our show IP route again, we will see that we now have a static route going to 172.16.0.0. And we know it's a /24, 255.255.255.0 network. And it's going via 10.0.0.2. Is our ping going to work? Well, let's test it. Test it. And our ping, by the way, is still not going to work. Why is the ping not going to work? Well, we have told this router how to get to this network, and this router will recognize its network, the 172 network here, but we have not told router 2 how to send the ping information back. So our ping does not work until we configure bidirectional routing. So we just have to configure this router here, router 2, to send packets back to the 192.168.0.0 network. So we'll go ahead and do that. We've got to be in global config mode to configure static routing. And we're going to, I'm going to move it this way so you can see the whole command. Same thing, keyword IP route, network we want to go to. Now we're going from router 2 back to this network that's connected to router 1. So it is 192.168.0.0 network. 255.255.255.0 is our subnet mask. And the next hop from router 2 to router 1 is the 10.0.0.1 interface. 10.0.0.1 interface. Now, I'm forcing the show IP route command here by typing do. If you know your commands, you can kind of force them. So that's all I'm doing there. And so here we can see we now have a static route going to 192.168.0.0. We're going to ping exactly the same way we did before. Ping 172.16.0.2, which is right over here off of our second network. And there we go. Our ping is successful. If you experience some problems, let's say your routes are showing up correctly in your routing tables, but you still cannot get the ping to work, then that would indicate to me that you may have a layer 2 problem. And the thing that's nice about a layer 2 problem, or maybe you just have your default gateway misconfigured on your PC. So let's actually go ahead and do that. So if I go to desktop here, and let's say I give myself the wrong default gateway. Let's say I let's make it 20. Okay, so I give myself the wrong default gateway. Okay, well, pings are not going to work then, even though our routing is correct. So we know that our routing's correct. But Is our ping going to work? Our ping is not going to work because our PC does not know how to get to its default gateway in this instance. So sometimes if you look in your routing table and your routing table appears to be correct, then you're going to want to go back and take a look at your PCs and see if maybe you've configured the wrong IP address or the wrong subnet mask or the wrong default gateway. So then the other thing you could try is you could try to ping just this interface. The next interface is 10.0.0.1. I mean, by now I would have checked my configurations on my PC by now, but maybe, when you're new to this, you try all sorts of different things. Usually you think there's something broken and it's not your fault, but let's try to ping 10.0.0.1. And we're not able to because our poor little PC is being sent to a default gateway. The packets are being sent to a default gateway that doesn't exist, right? So here we'll go back and we'll just reconfigure that correctly. See, so anything that's on our local area network, even though we've got, this incorrectly, as long as it's still on the local area network, so as long as we're pinging something on within the 192.168.0.0 network, that's still going to work because it doesn't even need to go to the router for that. The switch takes care of that. In fact, let's give it a try. Let's go to sorry, wrong spot. 192.168.0.3, and our ping works because we don't use the default gateway when we're within the same network. There's no need for it. So it's not always a routing problem. It can just simply be that you've configured something wrong on your PC. Let's fix this. Let's make this correct. And then you'll see we're able to get, oh, I keep closing that. We're able to get off of the network again. So we'll ping 192.168.0.3. That's working just like it did before. Now we're going to ping 10.0.0.1. Oh, we can ping it. Why? Because now the packet is going to the default gateway because it's off of our local area network. And this router, of course, knows its own directly connected network. And now that we've configured static routing, it will also know the 172.16.0.0 network as well. Well, this isn't the end of static routing. I know now that you probably love it because you understand the command and you want a challenge. I can feel it. You're asking me for a challenge. In the next lab, I'll give you a 4-router static routing challenge where you'll have to make the static routing work across multiple hops. Then after that, we'll combine static routing with VLSM. When you combine static routing with VLSM, then you're really starting to put things together. I really hope this made sense for you, and if it did, well then we're winning. Check back for new videos weekly, or so I hope, or just subscribe because then it's easier to know when I've posted a new video. Might not happen weekly. I've kept up a pretty good pace, but I don't know how long I can keep this up. So, if you subscribe, you'll know when I've posted a new video, and I know you're just waiting on the edge of your seat. All right. I hope you have a great week, and I'll see you next time. Bye-bye.